On the morning of June 3rd, 1998, a German family was enjoying their train journey, sipping coffee. The high-speed train was traveling from Munich to Hamburg. It was 10:30 a.m. with any wheel. Even if two punctures are made simultaneously on one side of a train's wheels, the weight increases, even if only by a few grams, at high speeds. This can cause vibrations. To solve this problem, wheel balancing is done, and the technician balances the wheel by applying an equal amount of weight to the opposite side. However, balancing loaded train wheels can be a very difficult task, especially if they are made in one piece. Replacing the wheels is not only difficult but also very costly. Therefore, German engineers came up with a new solution to fix this problem of ice trains, and that was reliant wheels. The special feature of reliant wheels was that they were not in one piece. The inner ring was separate and the outer part was made in a separate piece. A rubber ring was placed between the two to absorb vibrations. This design was specifically adopted so that whenever the outer wheel wore out, only that part would be replaced, not the entire wheel. This design was also being used on German trams at the time. However, the problem was that trams only ran at 30 kilometers per hour, while ice trains were supposed to run at 250 kilometers per hour. This was a major issue, the details of which you'll learn later, but at that time no one paid attention. Executives approved the design of the resilient wheels without any testing, and in 1992, these new wheels were installed on all high-speed trains. Everything went well for a few years, but in 1997, the Hanover-based tram company, Ustra, made a shocking discovery. They noticed cracks in the wheels of their trams. They replaced the cracked wheel parts and, as a precaution, informed Deutsche Bahn, Germany's national railway company. But since there were no complaints of vibrations in ice trains at that time, Duibin ignored this warning, and then exactly 1 year later, on June 3rd, 1998, everything changed. At 10:30 a.m., Ice Train 884 departed Hanover Station for Hamburg. The train had a total of 14 coaches, 2 power cars and 12 passenger cars. Inside, there were 287 passengers and 8 crew members. Everything seemed normal when it left Hanover Station. George Dittman was riding with his family in coach number 1. Their journey was going smoothly, but after a few minutes, something suddenly hit the floor of the train, and the next moment, something flew between 2 seats. A piece of steel tore through the floor and emerged. This sharp piece of steel was actually a piece of the wheel. Seeing this, George and his family immediately panicked, as if the ground had slipped beneath their feet. Had the iron slid in at the speed with which it had entered, his family would not have survived. He immediately sent his wife and children to the adjacent compartment and went to find the conductor. The conductor was in the 3rd coach at the time. George explained everything to him. But, as per company policy, the conductor, he couldn't stop the train until he saw the problem himself. So they both set off towards the 1st coach. The train was still running at 200 kilometers per hour, and the vibrations were slowly increasing. By the time the conductor and George reached the 1st coach, the train had already traveled 3 kilometers and was about to cross a dangerous section where the track split. A piece of the broken wheel still hanging beneath the train was sliding down the track. When the train crossed the first section point, the tire fell off and hit the track lever. And at that moment, something dangerous happened. The track switch changed. Now the 1st and 2nd coaches of the train were on one track, but the 3rd coach went onto the other track, meaning the front and rear would be in different directions. The train's body twisted and coach number 3 collided directly with the concrete pillar of a bridge. This horrific collision broke the bridge in half. Coach number 4 avoided collapsing but hit an embankment, crushing 3 railway workers instantly. Coaches number 5 and 6 were hit by the 300-ton beam of the falling bridge, buried under the concrete. The height of those 2 coaches was reduced to just 6 inches. Yes, just 6 inches. The remaining coaches coming from behind, 7, 8, 9, and 10, collided with each other at full speed and folded like paper. Only the first 2 coaches, carrying George and his family, survived. and the front locomotive stopped 3 kilometers ahead. The engineer and driver were certainly jolted when coach number 3 hit the bridge, but they were completely oblivious to the disaster unfolding behind them. Where this catastrophic accident occurred, there was a huge crowd. Nami was a small town. When the residents heard the explosion, they rushed to the scene. The scene before them was one they will likely never forget. Broken coaches, pieces of iron, fire, and screams. Some were trapped under the debris of the bridge, others were stuck in their seats, and the pressure-proof windows were so strong that they were almost impossible to break. Rescue workers had to call in heavy machinery, but it still took several hours to reach the first trapped people. More than 1,000 rescue workers were at the site. Ambulances and military doctors arrived and began the operation. A medical conference was taking place nearby. 40 doctors from there also reached the foreign site, but by then everything was over. A total of 101 people were killed in this accident. 88 people were found seriously injured, and around 100 suffered minor injuries. Those who were in the first 2 coaches were fortunate to survive. German high-speed trains, once considered the safest in the world, were once considered the safest trains. The Asiatic disaster shattered this impression. This accident shocked not only Germany but also people in France, Italy, and Japan, which share the high-speed train network. When investigators analyzed the entire site, it initially appeared as if a train had run off the tracks. But when they found a wheel component that had penetrated the floor of coach number 1, everything became clear. When logs were examined, it was discovered that the same wheel had previously reported a flat spot issue 8 times. Yet it hadn't been replaced. Cracks. Detection machines were available, but visual inspections were still conducted using a flashlight. The company dismissed the issue by claiming that the machines were false alarms. In 1992, Fraunhofer, a German research organization, issued a warning that resilient wheels could be dangerous on high-speed trains, and in 1997, the Hanover Trams Company also issued a warning. But both warnings were ignored. Engineers later explained that these tires rotated 500,000 times every day at high speeds. The steel tire would compress slightly and then expand again. This created fatigue cracks that grew larger and larger. The rubber in the middle absorbed the vibrations, and no one realized the wheels were actually cracking. Finally, on June 3, 1998, a single broken wheel caused a major disaster. The ET disaster is considered the world's deadliest high-speed train accident. Following this accident, the wheels on all high-speed trains were replaced with monoblock designs, and many bridges around junction points were rerouted, so that such an accident does not happen again. Germany reevaluated its entire railway system after this accident. Pressure-proof windows were replaced so that if there is a need for rescue in future, the people trapped inside can be taken out by breaking the windows. Even today, the Eichstätt disaster is taught as an example in the railway training centers of Germany. Monoblock wheels undoubtedly have higher maintenance cost and take more time, but at least they do not break at high speeds because they are cast in one piece, and vibrations are a signal that now the wheels need balancing.